what we're doing is we've been talking about how to use like select and where and all those. But I'm going to try and formalize things a little bit today, and then show you a little bit about how you can make these queries work a little bit more, how they can be a little bit more advanced. And so that's really what these slides are all about here. And so many of you will have seen this before. This is going to be kind of, I would say, it might be a review in some cases here, but it's going to be, Okay, so this is our basic database here. And again, I want to draw your attention to the fact that every piece of information here must be connected to the main database in some way. In other words, if you were to take your finger and trace it from one table to any other table, you should not have to pick up your finger. That means that there's always a path between one table and the next. There should always be a path, and that means that a relationship exists. And so what that really means in terms of queries is that when you write a query, you're really just looking to see whether a relationship exists between one table and another table. And so that is why we have to, we're making such a fuss about the relationship here. And so the relationship actually kind of comes together from this piece of code right here. This is your formal way of looking at your code here, or your query. So basically you have your select, and this is how you'll see this in some of the books, but select attribute 1, attribute 2, all the way to the last attribute here. Now, remember that each of those attributes has to come from a table. It has to come from someplace. That's how the relationship works. SQL will then go out to this table here someplace and find its way to wherever it's supposed to be according to your code, but the relationship has to be there. It has to be able to move around without ever, it has to be able to find a link between one table and the next. And so that link is really described on this line right here. So you're saying these tables here are connected to the database, and inside those tables I have these attributes. Now this part over here, where, we're going to be spending a lot of time talking about the where part, just to show you like how you can use what they call the predicate here. And the predicate is like your piece of information that kind of, it filters the data down in some way here. So for instance, you're basically not showing all the data in the table, or all the tables, but rather you're looking at the data according to some kind of requirements. And so that's your filtration, your filter here. So these R's, they just call those relations here. I don't know why they wouldn't just call them T for table, but it seems that every book has a different way of doing that. But as long as you recognize that this is your general form, then I think you'll be good to go. So your select statement here has some of its own keywords here that we'll talk about. And some of those keywords are, for instance, you have the select, as we've seen. We have the where, as we've seen here. Basically, it talks about which types of information or what kind of criteria are we're going to be using to view the information. But we also have other words like, for instance, group by, which means that, for instance, you can order the outputs in specific types of ways. You can have a thing here, and we'll talk about all of these here. I don't want to make it seem like I'm rushing through them. But there's another one here called having. All the ones in uppercase here. Having, for instance, is another type of a way of grouping. You can report specific types of data here according to traits of the data, like for instance, according to certain types of structures. We'll talk about that. You have order by. You have the ascending or descending order, so you can have things in alphabetical order or in numerical order. You can specify all of these things. And then you have this word here, as. And as allows you to use different types of wildcards that you might want to use. So for instance, you might have, you might return your table with specific types of letters, or you want to have all the names of this database that begin with A. And so you'll see all of these things soon enough here, but I want to put these on your radar so that you have an idea that it's not, the select statement is not just, it's not just this. It's actually quite sophisticated. And if you think about it, databases have actually come a long way here, and there's a lot of information that we use, in databases here, and so you have to have a very extensive way of getting at different types of information here, no matter what the size of the database. Just to give you an idea about how these things, I know we've seen these before, but I just wanted to drop the other shoe and put this up here so that you have an idea. But for instance, if you have a table here on the left here, table T, we have column 1 and column 2, or C1 and C2 here. You can see that the observation, the first observation has 1 for C1 and A for C2, and then the second observation has C2 is the entity for C2 is 2, and the entity for C2 the entity for C1 is 2, and the entity for C2 is B. I'm getting myself confused here. When you type in this basic command here, as we've done before many times, select star from T, that means just give me the whole table as it is. Don't remove any information, just send me everything here. Now, when you have something like this, select C1 from T, what that is doing here is that's actually kind of, now you're beginning to specify what information there is. And that's why databases are what they are. They don't just give us all the information when we want them, or when we ask for information, but they actually give us information that we're interested in seeing. Otherwise, we just use a giant list. So here we are selecting C1 from T, and that's really saying, give me the first column, or column 1, or C1, from table T. And then you can see on the right-hand side here, the result is just the column 1. Now you'll notice that column 2 just isn't shown. And so that's really what the essence is of databases. That's what it is, or that's what the essences are supposed to be all about, when you're not seeing everything. Now we can get more specific here, where this query on the third row down here says select star from T, where C1 is equal to 1. So now we're involving this where statement here, where we're actually bringing in some kind of condition. And the condition says, give me everything from this table where you see C1 is equal to 1. So that means that the actual mechanism here is that it's going to, when you print the whole table here, you're going to print the table in memory here. You don't actually, you don't say print the table, it means it loads the table in memory here. And then you'll have a parser in SQL, which is going to go through the C1 column, and anywhere where C1 is equal to 1, it doesn't matter what it's not looking at anything else. It just looks at that C1 column. And when it finds that condition is true, where C1 is equal to 1, wherever that is true, then it's going to show the entire row, which is the select star. And so if you think about your queries in terms of, of these basic examples, it will help you to write other queries. I know you've seen these before, but I think that they're a good reminder of how the queries work. Now, the next thing we have here is select star from T, and then we have this new word here, order by C1 descending, DSC, descending. And so what that's going to do is it's going to go through and it's going to look at C1 column, and it's going to make that a descending column here. So really it's selecting the whole thing. It's exactly what we've seen before, where it's like the select all from T. But now it's selecting everything from T, but it's kind of sorting, if you will. It's sorting C1 by the by its I guess it's numerical order now, and that's what order means. And so this is actually a very good. It's actually a very important piece to have here, because if your database is giving out names, you might want to give me all the names of the team players right now, and I want their names in order so that I can give them awards in some kind of alphabetical order. Excuse me. And so what this is going to do is this is going to give you not just the names, but it's going to sort the names at the same time. But I will say, though, that sorting does take time here. And so one thing that I'd like to mention is that if you are writing queries for some kind of banking system or something where you need speed, you sometimes have to consider whether it's really so necessary to order these things now, or whether maybe there's something else you can do. Maybe, for instance, you could, if you're running a program here that's working with a database, typically you'll have a piece of code that will work with the database, and then you just talk to the code, and the code talks to the database. It's one of your server things. But one thing you might do is you might have the code order the data once it's come out of the database, and that might be faster. Maybe it's faster that way. It depends. You have to do some experimentation to find out, but sometimes it's faster. But in this case, though, it's not a very big database, and so it doesn't make any difference at all. Now, I would like to take you through the T database here. And so this is I have a builder file that you can see up here. And this builder file is going to be found in your sandbox. And so if I can just go back to my area right here. In fact, what I'm going to do is I have all these files here, which is, I can see everything. But I'm going to take these files and I'm going to make a directory somewhere else where I'm going to work with these files here. I'd like to make a directory. I don't want to work with them in my sandbox, because if I change them, then it might make things difficult when I'm trying to download things later on. I think I already have a working directory here. No, okay. So I'm going to make a directory here called desktop working, in my desktop. Hopefully you can see what's going on here. I'm going to copy all this information there to my desktop. And then I'm going to, oops, I want everything there. Everything. So now what I've done is I use the slash or the -r, which is the recursive, and so hopefully that's given me every single thing. I don't know why I didn't copy over. Oh, you know what? Right. There we go. There we go. So now if I go to desktop working, oops. You can do this wherever you want. Sometimes you could, I mean, you could put it on a flash drive or something if that's easier. Who knows? If you don't have any space on your hard drive. But I usually take these files away someplace so I can work with them somewhere else, so that they don't clog up my sandbox directly on my class docs. So now you'll notice that we have these different files here. Inside an ls-l. I can't really get everything on one line here, but that's okay. Inside this directory here, campus db, I have. I'll just show you what's inside there. You can just type in this. You can see that there's a builder, and there's also a builder file for the T directory here. And so that's, and the builder T directory here, all the T database also comes with data. I'm going to run my server here, or my Docker container here. I mean, you don't have to, I guess, if you can't get it to work, that's okay. Okay, and then it's going to go inside my container, and now I'm inside. Now, the nice thing about this is that inside my container, if I type in who am I, you'll see that I'm suddenly root. I wasn't root before, but now I am. And that means I'm basically in my my container. And you can see that also by this line right here, that looks different from how it usually is, and that means you're inside your container. I'm going to go inside my T database here. And by the way, going back to what I was saying before, the reason why I'm here is because that means that if you're able to get inside your container, hopefully you are. If you're not, please see your technical leaders, and they'll be able to help you if you have a Windows machine. I'm really not a Windows person, so I think that your best bet would be talking to them about how to get into that, but it should be okay. Matty, I hope that it's worked for you. It has worked. Okay, good. I got to tell you something here. There's a sense of real relief that I think that computer scientists know when the code runs. It's like there's a rush that kind of comes through, and you're like, it works. Okay, so I'm going to build my T database here. And one thing that I'll tell you is that every time I give you a builder for one of your databases, this contains in fact, this is very similar to your lab. If you're working in your lab and you're having trouble with it, please look at this file, and this might help you with your lab here. You don't need to change anything here. It should work exactly as it is. Is it? Okay. I was like, oh my gosh, it's not working. Docker's not working. Okay, so you'll find that inside this build file, we have the same tables that we've been working on before, but I've made one change though, and that is that in the T table here, if you can see this, we now have another piece of information there. There's another attribute, which is the cost. That's a numeric value. That means it's just a number. That's actually called, this numeric is different from varchar. I could have used varchar, but I'm going to start using things like numeric and char and other things, because we're going to start talking about what's called the constraints, the entity constraints here, the integrity constraints here. And so what that basically does is it confirms that anytime you add some value to this cost, it has to be a number. Anyway, we'll talk about that integrity constraint later on. But basically, though, I'm going to start using actual identifiers for the data that that attribute is going to be holding. Now, so at the bottom of this file here, you have this file or this command. You can just go ahead and copy and paste. If I just do this, you'll notice that don't worry about these errors. The errors only mean that, for instance, if a table exists, which it doesn't, then build it. But actually, if the table, this is saying here that, for instance, I went to this the database. There was no table. Is that a good thing? And we expect there to be no table. If I ran this again, you'll see that there are no errors now, because what it's done is that I found the table, I've removed it, and now I've replaced it with a new table. So don't worry about the errors in here. They're okay, I can assure you. Now I'm going to go into my SQLite 3. Oops, I don't need that. I just need SQLite 3, and then there we go. And then if everything has gone well according to plan here, you should be able to build your data and have everything inside there. And so I can go ahead and I'll type some basic commands here that you can hopefully see where you are. Select all from, I can use upper or lowercase here, it doesn't really matter, upper or lowercase, and select star from T, and you can see that this is the contents of T. Now, last week what we had was the name, we had whether or not they're having tea, we had the sandwich type, and then this is new, this number here, that's the cost of the sandwich. This is the cost. I think the other tables are more or less the same. I can just go ahead and see here. The other about this, that's the same, and then session, is that the same? I think it's the same too. So really the only one that's changed is T. Now, the reason why I've made this change is because we're going to be using some constraints to work with some of the numbers that come out of the cost. Okay, let's go back to this and see where we are. So we have, I've just shown you a couple of these commands here. I've done the select star from department. Go ahead and run these things. I mean, just become familiar. It's like when you're sitting down at your prompt. If you're at your bash here and you're not in this database here, as soon as you get into, and the first thing you might want to type in is like ls to get a listing of the files that are in your local directory. This is the same kind of, this select statement right here is the same kind of thing here, where you're getting a list of kind of the information inside your table to kind of get a feel for how you're supposed to, or what kind of information you could get. So I tend to type this thing as soon as I get into my database, just to make sure that the database is populated, just to make sure that everything's there. I'm not actually using it to look for specific information, but I'm using this to see whether anything is in the, if my tables were populated correctly. Okay, there's a star missing for this next one here. Or actually, no, there's another command is, let's say that you want to go back to our, department here, and I don't want everything here. Let me just show you something here. I'm going to go back here, and if I'm doing a select all from, oops, spelling it wrong. Department, I'm still spelling it wrong. Department. Okay, now, one thing you might want to do is type in schema each time you type in a query. Because when you write your query, you're actually going to be accessing these attributes. So that's how your code is going to be written here. So now, if I wanted to find just the departmental information here, I could just type in this attribute right here, which is DEPT, and then I can get just that information there. Now, you'll notice that there's a lot of repetition here, and that's okay, because we're not just, we're going through the, order of this thing here. So notice the last 1, 2, 3, 4, 5. The last 5 departments here are geo. Well, that's because you're looking at this row, you're looking at this, then this, then this, then this. And so this query that I just typed in here, depart from department here, it just goes through this middle column here, and it doesn't care about anything else, and it just says that if this, or whatever this information here is, show it. That's basically what that's all about. Now, I can do this over here. I can see, I can add some other things here, where I can say, okay, well, let's count how many references for department there are. I can type in that, count. Count actually belongs to this whole thing here. It's actually a built-in command in your queries. Another thing I can do, which I think I have a slide later on here, probably on the next slide here, is I can do distinct. Now, distinct basically says, it goes through and says, okay, I find that there's a bunch of CS and there's a bunch of geo, so I'm just going to write CS once and geo once. And so what it does is it goes through and it finds all the possible classes of the, when I say classes, not like school classes, but the classes of data in terms of what the departments are called. And so that's like just going through and finding all these different things. Now, if I did the same, let's just try an experiment here, where I could type in not distinct. Let's just go ahead and say that I want to have, what was it, name? I forgot exactly what the thing is called now. ID. Okay, so let's do the ID. Select ID from department. Now, does anybody here see any repetition? Does anyone see the same thing twice? So it's not going to change anything if I were to type in distinct, because they are already distinct. In fact, I'll show you. I can count them. I'm going to make everything distinct, and then I'm going to count how many distinct things there are. In other words, how many different classes of that data are there? There are 11. Now, if I just go ahead and say, okay, well, let's just remove the distinct here and count how many things they are, whether they repeat or not, you'll see that they are 11. That is absolutely fundamental. That is characteristic of your primary key. That truth must exist. That means that you must be able to see that that if you do either if you count by a distinct elements in that column, or if you just count the columns themselves, the number should be the same. Distinct and the count should be the same. These two pieces should be the same here, because remember that your primary key is there to say, I confirm that this column is absolutely unique, and there's nothing. It's absolutely unique because of this at least one element here, which makes it unique. That means that there's no, even everything else might be repeating, this one thing doesn't repeat anywhere else in the column, and so that means it makes it absolutely distinct. And so if you're looking at some data and you have to come up with a primary key, we'll talk about primary keys, I think that's on Friday. But if you're talking about primary keys here, or if you're looking for primary keys here, you can run a simple test like this and see whether this number from the count distinct is the same as count. And if that's the case, then that should work for the data that exists right now on the table, that should be a fine primary key. But what I mean by that is that if you were to change the data and add more things, if you somehow had more, if you had, I don't know, if you introduced some kind of repetition, then that could be bad. And so that's why we have that primary key tag in the actual code itself, which I don't think I have in this particular code here. But we'll talk about that on Friday. I do. You'll notice that as I was looking at the departments over here, that means that this primary key code is going to, the code will complain if you try and add another piece of information in here, such as the ID is the same. That's, anyway, we'll get to that. And I think we've seen, there's an example of that, there's examples of that coming up. So I won't go through them right now. Right, okay, so then moving on to the next thing here. Yeah, here we are, here's the distinct. We've gone through some of that here. Now, the next thing is we have this distinct count. We've just gone through that too, which is very, very important. Sometimes it's necessary to find out like how many records there are in your database here, and so you can always use count for this. Now let's use another table here and see how this distinct business works. So if I go back to my code here, I'm going to try this distinct here. I'm going to select all from T and see what I get there. How many actual unique sandwiches are there? So I need to find out what the name of these things is. It's called sandwich. That's the attribute that I'm supposed to use. So if I go to select sandwich, I'll just do that without first. Ruben, PG, okay. And then if I can go back here and say, okay, well, give me the distinct. What are the different types of classes that I get here? Ah, here we go. So that basically means that if I were using this database to actually order these sandwiches again, and this is exactly what I did when I went through it, but I need to know kind of, when I'm giving people the order, we went to a place in town here to order these sandwiches. When I went to these places, I said to them, do you have Reuben's peanut butter and jelly sandwiches and chicken salad sandwiches on the menu? And they said yes. And I said, okay, great. Then you should be able to handle the order that I'm about to give you. And so I had to find out like how many Reubens we wanted, how many PBJs we had, and how many chickens we had here. So I could probably do something like from T, maybe I could change, oops, sorry, where, and I'll say, for instance, sandwich is equal to, I'll just put Reuben, if this work. Actually, I don't want distinct here, sorry. What I did was I said, okay, well, how many sandwiches of each kind do I need here? So I wrote a query that looked like this. And so you can see kind of what's going on here. So with this, I'm counting sandwiches here, but I have this where clause that's kicking in, and it says where I want to know how many times the sandwich is actually equal to Reuben. The actual quote, or the actual, the query itself is actually not very smart. It's just basically saying, go through this column here, sandwich, and tell me how many times you see the word Reuben. Count that. I could change this around. Let's see, how many times did chicken show up on here? Twice. And how many times did PBJ show up on here? 3 times. And so that makes sense if you think about it, because when you were just to go, if you just did a whole search of the table here, by the way, I'm beginning to put things in upper and lowercase. It doesn't really matter. I think we can see, we know where the commands are now. We know what the keywords are. They don't have to be in uppercase. Uppercase is usually there to help you to find them when you're looking through huge amounts of query. But for these, I'm not I'm getting sloppy here, but okay. It should be okay. So really, it's just gone through here. Now let's move into some other stuff that's kind of cool about these queries here. Another thing that I had to worry about when I was going back here was, well, we're talking about the where now, where I had to actually worry about, like, for instance, what was the price of these sandwiches, or what was the, there were some constraints that I wanted to subject my query to. And so I used the query, or I used the where clause to actually introduce conditions into my query so that I wouldn't just get everything, just as we saw. So let's just see here. I wanted to find out, in terms of the budget, I wanted to find out how many times, what kind of, what was the cost of these sandwiches? How many sandwiches were expensive here? So I have this over here, this next one here. So I did a, let's see if I can put this on the screen here. Select, actually I need to do this again. Schema. And I have this select star from T, where. Now notice that I'm using, where are we now? Cost. I'm going to go after this attribute right here. Now cost, going up here, remember, is a number. Just this number here. So that means if it's a number, I can subject it to logical constraints. So I'm going to say, okay, well, select everything from T where the cost is less than, say, 15. It's assumed that this is in dollars. And so you'll notice that everything now is you're showing the whole observation, the whole row here, for which the 15 is the upper bound. Show me everything that's less than 15. I could do other things too, where, for instance, I could say that where the cost is greater than 10. Okay, so it seems like most of the sandwiches are greater than 10. And if I wanted to find out ballpark how much, how many sandwiches are there, I could do a count. And there's 10. Or, for instance, I could say, let's change this around a little bit here. We can have some fun. And is it ID? Yeah. So I can say, show me all the IDs of the people here who are having sandwiches which cost greater than $10. Show me all the IDs, and also show me the, I don't know, what else do we have here? Whether or not they're having tea or not. Are they having tea? Yes or not? 1 or 0? Let's see what else we have to look at here. Show me, getting back to this T table here, show me, for instance, whether, well, let's have some fun here. Let's actually connect things together here. Let's say that this is all T here. I'm going to put T dot, I'll show you in a second here, but T here. So that's basically, I'm saying that I don't have to keep writing the word T, but I'm going to use this variable T for T here. Actually, I'm kind of getting ahead of myself here because there's a slide that we're talking about, but I'll get into it now. The next one here is I have D, and I'm going to call this the department. So there's a slide on this, so don't, if it doesn't make any sense right now, just ignore this and it'll be okay. I'm going to say, I'm basically saying that I don't want to type in the word T all the time here. I just want to use the word, I don't want to type in the word department. It's too much to type, so I'm just going to use the word D. And D, let's see, what can I go after in department? Room number, how about that? Room number. Okay. Now, if I went ahead and just pushed enter here, oh, you know what? Why does that not work? TID. That should work. I don't know why it's not working here. You know what? Maybe it's I put the T afterwards. Maybe I have to put the T afterwards. Sorry. There we go. The T has to go after, the letter T has to go after, or the D has to go after the department. Sorry, I goofed. Now, if I just type in this information like this, and hopefully I can get this all on one screen here, just barely. You will see that I get a bunch of stuff here, but remember though that just because something comes out of your query doesn't mean that query is correct. It's a logical bug in terms of computer science. And so you have to add some more information here. So and, now, actually let me just ask you. I'm bringing in these two tables here. How can I get information from both tables? How do I connect them both together? You have to think back to something that connects the tables together. You have to think back to the relationship in those tables. So I'll go back for a second here. Let's look at the schema. I have the T table, TEA, and I have department. And so I'm looking at the ID. Remember when we created this database, we connected everything with an ID? That was our relationship. That was the very thing that we used, going back here, to define this particular relationship. All the tables were connected by virtue of the fact that they shared common IDs. That was, you have to have that relationship there. In absence of the relationship, it's not going to work, and everything goes horribly wrong, horribly wrong. So going back to my half-finished quote here, I need to connect ID from the T table with ID from the department table. Isn't that right? So I'm going to do that by just saying and. This T.ID equals D.ID. And that's basically saying that go back to the T table here. The ID there, oops. The ID for the T table should be equal to the ID from the department table. This is one way of writing it down. In fact, I'll go back and change this just to make it. I can change this around if you want, just to make it go back to the way we're used to seeing it. Where cost. Actually, that cost was, since that's the only cost, that doesn't really matter. If I have different costs from different tables, then I have to worry about being precise about which one it is. If this will still work. I think this is always good, I guess. There we go. It's the same query. So here I'm just actually labeling these by department number, but the other one I'm using here allows me to abbreviate things. And there's a slide on that, so I'll wait until we get to that slide to talk about that more. Are there any questions over this whole thing? Is everyone? Are there any questions online, for instance? If you have any questions online, please let me know. I have my Slack open here now, and okay. Anyway, if you have any questions, let me know. I'm going to get back to the slides now. Let's go back here and see what else we can do. So now this is the where clause here. The where is it's very powerful. And so this is the one that we just did here, or at least something very similar to it, where we connected together the department ID and the TID. That was our relationship. We had to go after some kind of relationship to bring those two tables together. Because if we don't, then it just gives us a whole bunch of information, which is really the Cartesian product of both of those tables. And so it doesn't mean that it's correct. I mean, there are some correct answers in there, but a bulk of it is going to be wrong. And so you have to bring everything together with this connection here. Here's another connection here where I'm bringing things together from two different tables. Here I have the departments. From the department table, I'm grabbing the depth attribute. I want to see the T. From the T table, I want to see the sandwich. And then I have to connect those two tables together. In fact, I think if I just copied this, would it just work? It might just enable just to copy and paste this in there. If I copy and paste things together, it doesn't always work because you have to make sure that there's like spaces in there. Somehow spaces, I don't understand how to fix this, but sometimes spaces, you see them on the slides, but they don't translate into them when you paste them into SQLite. So do check for spaces if you're trying to copy and paste your code. It's probably a space issue. Okay, so I think you have an idea about how far this is going. One thing I'd like to draw your attention to, though, is that going back to the count command here, I can do a count here, I think. Maybe it won't work. Let's just try this here. Okay, it doesn't work. It doesn't work because count doesn't like working with more than one attribute. So if you're going to do a count, you can't use two different attributes together. For some reason, it just makes it confuses SQLite, and so count doesn't work. And so what I would recommend, though, is that if you're trying to do a count on this information here, the constraints are all correct here. The where predicate is okay. So leave that and just remove one of these things here, and then that should work just as well. Just remove one of the, or just have only one attribute remaining, and that should show you what you want to know. Okay, so that's basically where here. There's some other things here you can look at too if you'd like to see. I've just had some other information here. There's some other simple queries along the same lines of what we're talking about now. where we're connecting different tables together. This is one that's a little bit more robust, I think, than what we had before. Let's just try this one and see what happens. This is saying find out who is presenting a poster, what kind of sandwich this person is having, which costs over, as long as the sandwich is over $10 here. So really it's saying, give me all the people who have a sandwich that's over $10, and show me what poster they're presenting, or whether show me if they're presenting a poster or not. Hopefully this will work. Session ID. Oh, you know what? I need to put this into. Sorry guys, I'm going to put this into my editor, where I'm going to move things around a little bit here. Session ID. That should work. Oh, you know what? It's this piece right here. I'm going to copy that. Go here. There's no such thing as poster. It's actually, what do we have in there then? Oh, it's in lowercase. That's what it is. Sorry, this doesn't work. I'm gonna try. Oh, I know what it is. I know what it is. It's the quotes always cause problems here. If you see these funny quotes here, they always cause problems, and so you have to change the quotes around a little bit here. So I've just copied it. I'm gonna go back here. There we go. Excuse me. So this is saying, let's go back to the query, and it says, everyone who's giving me a poster of the session here, tell me their names if their sandwich costs more than, what was it here? More than $10. So that's the data here. So the reason why I'm actually bringing all this stuff up here, why are we spending so much time talking about these slides here? And that is because it is easy to write the query, I would say, but it's difficult to figure out like what information you're supposed to actually go after to make that query give you the answer that you're looking for. So when you are coming up with a query here, when you're writing up, like for instance, for all the people who are presenting a poster, tell me who is ordering a sandwich that costs more than $10 here, you have to take a moment here to think about what the logics of that is all about. And that's where things get difficult. And so what I recommend is that as you are studying your queries here, spend some time to look over these kinds of queries, or for instance, what I did when I was learning databases is I created a database, in fact, very similar to this, very simple, which I kept on adding more and more stuff to. And the idea was that I would write queries that were able to give me information, and I knew that those queries were ridiculous, but the syntax was correct. And so I could find other ways of, like, bending that syntax into for use in other databases. And so that's how you learn this stuff. You just have to kind of choose something that appears to work. Okay, let me just move this down a bit there. Okay, so that's that. I'm going to move back to my my slides here. The next one I want to spend some time looking at is another database, same type of idea here, where we're going to be running some basic queries. But it's a little bit more complicated. It's the campus database here. And so let me just go back and get that fired up. And so over here, I'm going to type in .exit exit. By the way, one thing I have to tell you, I just have to tell you this. Please exit out of your database by typing in .exit. Do not click on the X in the window here. In my Mac here, I have a red X that actually makes the window go away. Don't click on that, because if you do that, you're basically crashing whatever program is being run by bash. So I'm running bash, that's what the blue window is here. But inside bash, I'm running another program. And so if I crash bash, if I crash the bash, then that means that whatever the bash is running also crashes, and that means that I might lose data. And so if you're building a database where you have a file name in there, then all the changes that you add to this thing are being recorded in that file, and then they're all saved when you type in .exit. I think they're actually being saved as you go, but if you type in exit, you're sure to save everything. Everything is saved. But if I just click this window just to close it, it's not a window that works that way. It will lose everything. You're actually crashing SQL. Okay, so I'm going to get out of here. I'm going to go into my campus database, which is right here. I have my builder. Check your builder. At the very, very bottom of the builder, again, I'll always leave you these these commands you can use here. You just copy and paste that, and that will then build you a new database with many, many more tables. And the data is all built in, by the way. You have, that's what all these lines are right here. That's actually populating the data. Now, I know what you're thinking. What was all that stuff we talked about in lab and earlier when we were using the import statements? Well, you should be using import statements, but for demonstrations like this, I just give out these files here. So it's just, you just run the one, you just have one file and it's all together. And you don't have to worry too much about doing other things. For the T directory, though, for the T database, I did use the files. I did actually load or import files there just so that you can see how it's done. But I think that for some of these databases, when I give them to you, I'll just give you a file that has everything included so that it's just easier for you. You don't have to worry about that. But you should still know how to import your files here. Right. Okay, so type in, provided that everyone's got their database to build, did anyone have any trouble with that? And online, did anyone have any trouble? If you did, you can always unmute yourself and say something. But otherwise, I'll assume that everything went okay. If I type in .tables, or table here, tables here, table or tables, you'll see it's exactly the same command. I don't know why they have two different commands that do exactly the same thing. That seems almost inefficient. But again, I can type in a select just to see what's inside course. Why not? Whoops, select all, whoops. Ugh. Goodness gracious, sticky fingers. So you can see that what's going on. Let me just show you that what we have in this database here. So if I type in schema, this is a database which is similar to what they would use in the registrar. It's not exactly the database they would use. They have many, many, many more things there, but for this database, though, it's a model of the registrar. I wanted to give you something that's not just T and session and department, but something that's actually a little more useful than that. So you can see how this stuff comes together. So the teachers table here has an ID of the these are all the these are the courses, I guess. These are the professors who are teaching different types of courses, and the ID is supposed to be the name of the teacher who is teaching that course, I believe. I can type in a select all from teachers and see what's in there. Oh, sorry. So the ID is actually, sorry. So the ID is going to be the course ID. This is going to be the course name. Goodness gracious. Teachers. Okay. So the first thing is going to be the ID for the class. Then you have the course ID, which is like your CS class number. Then you have your section. That's your like when it's going to be offered in some semester, I guess. Semester is going to be fall or spring, and then you have the year, which is the year right here. So that's that. And then if you go to, let's see, let's look at the next table along here. Teaches is here. Let's look at the department here. I'm going through this because it's important to spend some time to get an idea about what the data is in the database, because that will inform the kinds of queries that you can use here. So now in department, the first thing is going to be the course ID, and that's represented by this over here. The next thing is going to be the course type, whether it's a CS or math or computational biology, history class, philosophy, French or English. And then the department name is going to be the actual full name of the department here. And so you can get an idea that there does seem to be some repetition in these databases here. They're not 100% efficient, but actually they're not bad. You can always just use, instead of like typing in Phil, PHL, just use philosophy. Why do we have to have this other column here? In this case, it's small enough so it doesn't matter, but if this database were colossal, like really, really, really big, then you might consider really reducing the amount of columns you have here because you have to keep all this stuff in memory when you're running it. With this particular type of database, all this stuff has to be loaded into memory in order for you to work with it. Let's go to the next table here. Instructor. So schema, instructor, oops, T, there we go, that's silly me. Let's see, instructor. Anyway, I guess you kind of get an idea. We're basically out of time now, but what I was going to do though is I might leave some of this work for you actually in your own time. That is that we have this database now. We've just spent some time kind of going through this. The instructor table, you can kind of get an idea about what information is there. And you'll see that in these slides here, this slide right here is the abbreviations that I discussed earlier. where you change instructor with I. But you have some queries that you can try out here. Go ahead and try these queries out. When we come back on Wednesday, we'll spend some time to go through some of these things here, and I'll take some time to explain how they work. These are the aggregate functions here, which are actually they're very powerful functions that you can use to like get the min, max, sum, count, and average of some of the numbers here. But please do look at this on your own time, and then on Wednesday when we come back, we'll go through the queries and get an idea about how everything comes together. Alrighty? Didn't mean to take so much time getting ready here. I guess we have an overloaded class today. But as always, if you have any questions, let me know. So users at home, let me know how I can be helpful. See you soon. Everyone stay well.